Okay, so the next thing that we're going to talk about here is the operations of complex numbers. As a note, we'll write all of our answers as a complex number. Okay, that is, write them all in the form a plus b times I. So the first one, negative 5 plus 3i plus 7 plus 8i. We've got two complex numbers. Now, whenever you're adding or subtracting two complex numbers, it's very simple. All you do is add the real parts together, and then you add the imaginary parts together. So like here, negative 5 plus 7 is 2. Negative 3i plus 8i is 11i. 2 plus 11i, that's in the form a plus b times I, and so we're done. 8 minus 6i minus the quantity 13 minus 2i. 8 minus 13 is negative 5. Negative 6i minus 2i is negative 8i. Negative 5 minus 8i is in the form a plus b times I, and so we're done. Okay, now with multiplication and division, it's kind of different. Suppose with multiplication, suppose we have the square root of negative 16 times the square root of negative 25. Well, the square root of negative 16 is 4i. I've already done that one. The square root of negative 25 is 5i. 4i times 5i is 20i squared, and I squared is negative 1. So 20 times negative 1 is negative 20. Is this a complex number? There's no I. Yeah, this is a complex number even though there's no I. Remember, A and B can be any real numbers, including 0. So a plus 0 times I is a complex number. So you guys have actually been working with complex numbers your whole life, and you didn't even know it. B was always 0. Okay, so negative 20 is a complex number, which means I can circle that. Now, one thing that students will do is that so like for example, the square root of negative 16 times the square root of negative 25, they'll take away any imaginary form, and the square root of negative 16 times the square root of times the negative 25. Negative times negative is positive. 16 times 25 is 400, so you got the square root of 400, which is 20. Hold up, so what's the answer then? Is it 20 or is it negative 20? Well, negative 20 is what I got circled. 20 would be incorrect. You see, if x is less than 0 and y is less than 0, then the square root of x times the square root of y is not the same as the square root of x times y. That's an important note. So the first thing that we have to do is we need to think about what this is in terms of a complex number. 4i times 5i, that is step 1. Step 1 is not to get a single radical out of this. Okay? You would end up getting the wrong answer there. Okay, so negative 20 is a complex number. Here's one. 1 plus 2i times 1 plus 3i. So the natural thing that somebody would want to do here would want to FOIL out. 1 times 1 is 1. 3i times 2i is 3i plus 2i is 5i. 3i times 2i would be 6i squared. I squared is negative 1. So really what we're doing here is we're subtracting 6. 1 minus 6 is negative 5 plus 5i, and so now we've got a complex number. Okay? 3 minus 7i squared gives me 3 minus 7i times another 3 minus 7i. So when I FOIL this out, 3 times 3 is 9. And then 3 times negative 7i, that's negative 21i, minus another 21i, gives me minus 42i. Negative times negative is positive. 7i times 7i gives me 49i squared. I squared is negative 1. So really I have to take 9 minus 49, which gives me negative 40, and then I get the minus 42i. Negative 40 minus 42i would be my answer. Okay? And notice how I'm going as far as possible on every one of these, going into the form a plus b times I. Okay? Another one, 5 plus 6i times 5 minus 6i. Well, that's going to be a FOIL it out. 5 times 5 is 25. And when I FOIL this, the middle terms are going to go to 0. So here's, check it out. Negative 30i plus 30i is 0 in the middle. 6i times negative 6i is negative 36i squared. I squared is negative 1. So 25 minus negative 61. That's the same as 25 plus 36. 25 minus negative 36. That's the same as 25 plus 36. 25 plus 36 is 61. Now, is 61 a complex number? Is that in the form a plus b times I? Yeah. Yeah, it is. B is 0. Okay, so 61 plus b times 0, plus 0 times I is correct. I normally don't write plus 0 times I, okay, but I could. So 61 is a complex number. Any number is a complex number. Okay. Another one here is division. 2 divided by 3 plus I. Well, 2 divided by 3 plus I, you want to multiply the top and bottom by the complex conjugate of the denominator. The complex conjugate is where I change the b value to its negative. So 3 plus I, the complex conjugate of that would be 3 minus I. I'd want to multiply by 3 minus I times 3 divided by 3 minus I. Now that's the same as 1. Okay, so I'm not actually changing anything if I'm multiplying by 1. And you can think of this as similar to rationalizing the denominator. So I have 2 times 3 plus I divided by 9 minus I squared. Again, the middle terms are going to go to 0 when I FOIL it. So 2 times 3 plus 3 minus I divided by 10. 2 divided by 10 is 5. 3 minus I divided by 5. Well, that's the same as 3/5 minus 1/5 times I. Okay, and that's the answer then. That's the complex conjugate. That's a complex number. A plus b times I. If I take 2 minus 5i divided by 1 minus 6i, well, the complex conjugate of 1 minus 6i is 1 plus 6i. So let me multiply by 1 plus 6i divided by 1 plus 6i. There's no harm in doing that. I'm just multiplying by 1. Okay, but the reason, see the trick in division is always to multiply the top and bottom by the complex conjugate of the denominator. Okay, so in the denominator, you see, notice how anything involving I is going to go away. In the denominator, I've got 1 minus 36i squared. The middle term goes to 0. That's the same as 1 minus negative 36, or 1 plus 36 is 37. Now in the numerator, I've got 2 plus 12 minus 5i plus 12i minus 5i is plus 7i minus 30i squared. I squared is negative 1, so I'm really adding 30 here. 2 plus 30 gives me 32 plus 7i divided by 37. Now technically that's not in complex number form because I'm not dividing by a single number there on both the terms. So I want to take this a step further. 32 divided by 37 plus 7 over 37 times I. Okay, and that would be as far as I can go then. That would be my number in the form a plus b times I. Where are we at here? A plus b times I. A plus b times I. Okay? So go as far as you can on every single one of these until you're in the form a plus b times I. Okay? Page 224 is where you'll find the homework problems at. Be sure to look at those problems when you get a chance. Okay.